All right, so let's look at this question here. So they're saying a golfer is practicing on an elevated tee, okay, 4.9 meters above the ground. The ball leaves the tee with a velocity of 20 meters per second, okay, at an angle of 32 degrees to the horizontal. All right, how long does the ball take to hit the ground? So this one here is the same as the time of what? Flight. Okay, it's the same as time of flight. And then what is the range? They just want the distance from where this thing started all the way to where it's landed. Okay, calculate the speed of the ball after 0.8 seconds. So we find the final speed, okay, in terms of the x direction and in terms of the y direction. And then we combine those components to find the speed. And then the last one there was find the striking speed of the ball as it lands. Okay, so we're also going to find that. All right, so let's start with the first one here. So they're saying, how long does the ball take to land? So I'll redraw this diagram here with just lines like this. So this is the cliff, and we're told that this guy here is 4.9 meters above, like that. Okay, and then he hits this cup ball, okay, such that this ball starts with an initial velocity from this point here. So it starts with an initial velocity. Okay, it starts with an initial velocity like that. Okay, and then the angle which is there, we've been told it's what? 32 degrees, like that. Okay, and then the magnitude of this velocity is actually 20 meters per second. So this guy here, this projectile motion, it moves on top like this, and then it comes down to this. Okay, so now the distance from this point where it's starting from all the way to where it's ending, this distance here, is what we are calling as the what? The range. Okay, is what we are calling as the what? As the range. All right, so how long does the boat take to land? So how long does the boat take to start from this position to move all the way up to this position? Okay, so whenever you're calculating time, always use the motion in the what? In the y direction. Okay, whenever you're calculating time, always use the motion in the y direction. Okay, so first of all, we need to resolve our velocity into the y component and the x component. Okay, so this is the velocity there. So I have my y component there, then my x component there. Okay, so my x component will just be 20 cos the theta there, which is 32. And then my y component of this velocity 20 will be 20 sine 32, like that. Okay, so now to find the time, remember this equation here. Okay, remember the equation that we were using. So we said we have this equation where we say x, okay, or s is equals to the initial velocity multiplied by time, okay, plus what now? Okay, plus half, okay, plus half, and then we have okay, plus half, and then g t squared. Okay, remember this equation there. So now what we're going to do here is that we're going to write this equation in terms of the y. Okay, because when finding time, we always use the y direction. So this s now is just the distance. So I'll replace it with y to show that now I'm in the y direction. So that will be y is equals to, this initial will be initial in the y, t plus 1 over 2, and then g, and then what? Times squared. So this is what we are going to be using here. Okay, so now this guy here starts on top here, and then goes above, and then it comes down. Okay, so initially, okay, initially its velocity is going above. So that is opposing gravitational, the gravitational, the g, okay, it's opposing the g there, which is the gravitational acceleration, okay, because it's going above like that. We all know that the acceleration due to gravity goes down, right? So the velocity is opposing the g. So since initially it's opposing the g, it means my g in this question, I'm going to get it as minus 9.8. Okay, and then another thing is that this is the distance here. Okay, this is our y. So even our y, we are going to get it as a negative y because we are starting at a point which is above the ground, and then we are moving further above, and then we come down like this. So it means this distance here, or this height here, is going to be taken as a negative. So that would be minus 4.9. Okay, and then my initial speed in terms of the y is this guy. Oh, that is in terms of the y. It's this guy here. So uy is this one here. So I have everything to find my time. So here, this will just be my y. I'm taking it as a negative. So that will be minus 4.9 is equals to. Then my uy, it's this guy. So that will be 20 sine 32. Okay, that will be 20 sine 32. Um, and then multiplied by the t that we don't know. And then this will be half, okay, plus half. The g is minus 9.8 because initially the motion is opposing gravitational acceleration. And then t squared, I don't know it. Okay, so that would be just be minus 4.9 is equals to this part here, 20 multiplied by sine 32. That would be 10.6. So just round it off to one decimal place. So 10.6 t, and then that would be minus. So here, half multiplied by 9.8. That's the same as dividing by 2. So that would be minus 4.9 t squared. So you see that we get like a quadratic equation, right? So we just use the quadratic formula to solve it. So I'll first take all of this to the other side. So that would be 4.9 t squared. Okay, and then this one, when it goes to the other side, to be minus 10.6 t. And then combine with this, minus 4.9 is equals to what? To 0. Okay, so that is what we have. So want to find t, which is the time. Okay, want to find t, which is the time. So to find the t, we have a quadratic equation here. We're just going to solve the quadratic equation. Okay, and then once we solve that quadratic equation, we're going to get two answers, a negative answer and a positive answer. So we know that time can never be negative. So we're going to pick the positive ones. So if this is our quadratic equation, then my a will be the coefficient of the variable, which is squared. So that will be 4.9. And then my b, okay, it will be minus 10.6. And then my c, it will be minus 4.9. And then I just write the quadratic equation in terms of t, because here my variable is t. So that will be t is equals to minus b plus or minus the square root of b squared minus 4 ac divided by, okay, divided by, divided by 2a. So this will just be equals to minus, the b is minus 10.6. So careful with the signs, plus or minus the square root of the b squared, that will be minus 10.6 squared minus 4. The a is 4.9. Okay, and then the c is minus 4.9. Okay, so that's what we have, and then I'm dividing all this by 2 multiplied by the a. Okay, so what are we going to get from that? So, okay, so this will be, hey, what's happening now? This eraser is not going away. Anyway, okay, so we have equals is equals to this negative multiplied by this, that will be 10.6, okay, plus or minus the square root of, inside there I have minus 10.6 squared, okay? I have minus 10.6 squared. Okay, so let me write it. Minus 10.6 squared, okay? And then I have minus 4 multiplied by 4.9 in brackets. And then in the other brackets, I have minus 4.9. Okay, and then I close. So what I end up getting there will just be what? Okay, so inside there, getting what? Okay. Okay. What is my calculator saying? Okay, let me redo this. So under the root there, okay, under the root there, we have what? Okay, I have minus 10.6 squared Okay, and then I say minus 4. And then in the brackets, I have 4.9. And then in the other brackets, I have minus 4.9. Okay, so the answer that I get, and then I get the square root. So here, if I get the square root of all these things that is under the root there, I'm getting this number. So I'm getting 14.43606595. Then I'm dividing this by 2 multiplied by 4.9, which will just be 9.8. Okay, so as I said, we're going to get two answers. So if you do 10.6 minus 14, that will be a negative answer. So we don't need a negative answer. So the only answer that we are interested in is when we add the two things that we have on top. So that will be t is equals to, so 10.6 plus this. Okay, so plus 10.6, and then I'm dividing by, okay, I'm dividing by, okay, so divided by 9.8. Okay, so what I get as my time, it will be 2.554700607. So counter check with your calculator. So meaning my time will just be equals to 2.6 seconds. Okay, so this is the time of the flight, or how long the boat takes to what? To reach the land. So from this point here, as it goes all the way in the trajectory like this, all the way up to this point, it takes this time. Okay, so if it takes this time to move in this direction like that, it means it's the same time that it would take to move in this horizontal way. Okay, so the time there will just be 2.6 seconds. And then the next question now there was asking us to find the range. Okay, so the formula for the general range is that x, which represents range, is just equals to, okay, it's just equals to the u cos theta, which is, this here is simply saying ux like this, okay, then multiplied by time. So this will just be equals to, so u cos theta is this guy, so that will be 20 cos 32, then multiplied by the time. So the time, you get the time for the whole flight, which is what? 2.6 there. So I multiply this, I'm going to get my range as okay, as 3.4 meters. Okay, or any number which is very close to this. So make sure you counter check with your own calculators if you're finding the same ones. Okay, so that's our range. And then we go to the next question. Okay, so if you have any questions, just ask. So this question now, which is the next question here, they're asking us to calculate the speed of the ball after 8 seconds. Okay, so as this guy is moving from here, as it's moving like that, when the time reaches 8 seconds, they want us to calculate the speed of the ball. So since this is projectile motion, okay, we have a vertical speed and a horizontal speed. So to calculate the speed of the ball after 8 seconds, we first have to find the horizontal speed after 8 seconds and the vertical speed after 8 seconds, and then we combine those, okay, to find the resultant speed after 8 seconds. So I'm going to say the speed in the x direction and the speed in the y direction. So in the x direction, the acceleration is always 0. So simply meaning that the initial speed ux, okay, is equals to the final speed, which is vx. Okay, that is in the x direction. So it will just be this same 20 multiplied by cos 32. So 20 multiplied by cos 32, that will give me about 16.96. So that will be 16.96 meters per second. So this is this initial and the final speed in terms of the x, okay? But in the y, okay, in the y, my initial, which is uy, will be this guy here, which is 20 sine 32. So 20 sine 32 is going to give me 10.6 meters per second. Okay, so it means now I have to find the final, okay, speed, okay, after what? After 8 seconds. Okay, because this one here, the one in the x, it's constant, so it doesn't matter if it's after 0.8 seconds, 1 second, 4 seconds, it will still be the same. But this one, the initial is 10.6, but after 8 seconds, okay, what will happen to the what? To the vertical speed. Okay, so to find the vertical speed, okay, to find the vertical speed, we're going to use this formula here. Okay, so we're going to say Vy is equals to Uy plus GT. Okay, just like the one we used on the previous question. So now my final velocity in terms of the y, I don't know it. So that is my Vy is equals to my initial Uy is 10.6. Okay, and then I'll say plus G. Okay, we said the motion here as we start our motion, this is opposing motion. So the G is a negative 9.8 like this. And then the time, okay, is what? 8 seconds, because they said after 8 seconds. So that would be 0.8. So now I just punch all this onto my calculator. So I'm going to find that the speed, okay, or the final speed after 0.8 seconds, sorry. Okay, the final speed after 0.8 second is found to be 2.76 meters per second. Okay, so that's the final speed there. So I'll write the final speed here after what? 0.8 second. So that would be 2.76 meters squared. All right, so that's what I get. All right, so now to find the speed, I'll just combine the final speed after 8 seconds, which is this because it doesn't change, and the final speed after the 0.8 second there. So it will just be the speed, okay? I can even write here after 0.8 second will be equals to the square root of, okay, the final speed in the x after 0.8 second, which is this same guy, 16.96 squared, plus the final speed in the y direction after 0.8 second. So that will be 2.76 squared. Okay, and then I just punch this now into the calculator. Okay, so this guy here, when I square it, it gives me 287.7 plus. When I square this guy, I get 7.62. So counter check with your calculator. Then when I add this and then I get the square root, okay, I just find that the speed, okay, of the ball after 0.8 second will be 17.2 meters per second. Okay, so any questions there? Okay, so if there are no questions, let's find the last one. So the last one, they're asking us to find the okay, the last one, they're asking us to find what? Okay, so maybe I can keep this. They're asking us to find the speed of the ball as it strikes the ground. Okay, so simply meaning the speed of the ball when it reaches there. So he said when it reaches there, how long did it take? It took 2.6 seconds. That's what we said. So they're just asking us for the speed of the ball after 2.6 seconds. Okay, that's what they're asking us. So we're going to do a similar thing that we are doing. So now we need to find the final velocity after 2.6 seconds. So since this is projectile motion, we need to find the final velocity in the x direction, which does not change. Okay, and we also have to find the final velocity in the y direction, which changes. So the one in the x direction is already sorted, but we have to find the final in the y, which we said was just initial in the y plus, okay, the g multiplied by the what? By the t. Okay, so this will just be equals to, the initial is 10.6, then plus the g, because the motion here initially is opposing, okay, gravity, we're going to say it's minus 9.8. And then the time, okay, when it reaches here, we already found it is this 2.6. So we put 2.6 there. Okay, and then we multiply this to see what we're going to get. Okay, so once I do that, my final velocity, okay, I find it as minus 14 9.5, okay, meters per second. So this simply means the velocity is just reducing, okay. All right, so if that is my final velocity, okay, I've used this formula to find it, okay. But if you want, you can use another formula, okay. So let's try to use the other formula to see if we are going to find the same thing, okay. So the other formula is this guy. Oh, I've rubbed now. So uh, the other formula here, so here I was saying don't worry about the negative here, just simply showing you that the velocity is reducing. Okay, so that's simply meaning the velocity is reducing. And when we put it in that square root of the square, the negative is going to cancel. Okay, but if you want, okay, in case there was no such a question here for finding how long it takes and you don't have the time, okay, you can use this formula to find the final velocity in terms of the what? Of the y. So you say final velocity in terms of the y squared is equals to the initial in terms of the y squared, okay, and then plus 2g, okay, 2g multiplied by the distance y, okay, multiplied by the distance y. So vy squared will just be equals to um, this initial velocity in terms of the y, we said it was what? 10.6 squared, this one here. So we square it, then plus 2. The g, since initially the motion is opposing gravity, it is minus 9.8. And then this one is this y here. Because it's starting at a point above, and then it's going above again and then dropping down, we're going to get it as a negative like this. Okay, and then what do I get once I do this? So I have 10.6, okay, so 10.6 squared plus 2 multiplied by minus 9.8 multiplied by minus 4.8. Okay, so I get, okay, I get what now? Okay, so I get about, okay, so I get 208.4. And then remember here at Vy squared. So I just want my Vy. So you take the square root of both sides, okay? You're still going to find this guy here, which is 14.4 something something. Then I just round it off to 14.5. So you can use this or you can use the other one. Right, so now that we have the final, okay, velocity in terms of the y and the x, we can simply find the velocity. So this will just be the square root of 16.96 squared plus 14.5. If you want, you can put minus 14.5 because you're going to square it, it doesn't matter. So this will just be equals to, okay, so what I find there will be 22.3 meters per second. All right, so that is my velocity there as the ball strikes the ground. Okay, so as the ball strikes the ground, that is my velocity. All right, so any questions there? Any questions there, guys? Okay, so sometimes I'll add one more question here. Sometimes they can ask you for the angle or the direction. Okay, they can say find the angle below the horizontal made by the velocity vector. So this is the velocity that we found, but what angle does it make um, below the horizontal? Okay, so below the horizontal, this is the horizontal. So this thing is coming like that. So below the horizontal, okay, what would be the angle that this velocity will be making? So that angle will just simply be what? This angle here. So we want to find that angle there. So that is another question that they can ask you. So how do we find that one? We simply use these um, final velocities in terms of the y and the what and the x. So this one here, it's 16.96. So it's going to the right like this. So this is 16.9 meters per second. This here is a minus. Okay, so I'm going down like this. So that is my 14.5. Okay, so I'm going down here because I have a minus there. Okay, and then the velocity is just going to be in between like that. So I want to find this angle here. So how do I do that? Okay, I just use the simple formula from the tan. Okay, I just use the simple formula from the what? From the tan. So I'm going to say my angle, okay, which is this theta, is just going to be equals to tan inverse, okay, of the final speed in the y. So that would be 14.5 divided by the final speed in the x, 16.9. So I'm just going to punch this now on the calculator. So to be the tan inverse of 14.5 divided by 16.9. Okay, so the angle there will be 40.6 degrees. So in case they ask you for the angle, that's how we can find it there. All right, so any questions there, guys? I think that's enough for today. All right, so if you have no any other question, then we end here. Okay, but all those who have been missing our other lessons, okay, we have full lessons available on our website. Okay, so you can just go to Chrome and then you search. Okay, so you search discretelearning.com. Okay, hey, what did I search now? So discrete. Okay, let me do this. So discretelearning.com, and then you go there. Okay, so if you don't have an account, make sure you create an account here because all the lessons that are recorded are going to be on this website and you can access them anytime that you want. Okay, so once you log in, you can see the courses that we offer there. So you can subscribe for any course that you want. Okay, math, chemistry, physics, biology, whatever course that you want. Okay, so once you subscribe for that course, you're going to find topic lessons, past papers, as well as the tutorial sheet solutions. So for example, if I go maybe, which one should I use here? Okay, maybe I just go in math and then you go in general mathematics here. So general mathematics, you're going to find the topic lessons, summarize notes, tutorial sheet, and the past quiz, test, and exam papers. Okay, so if, for example, you go in topic lessons here, you're going to see that you're going to find the topics well arranged. So all the topics that you're going to do, from set theory all the way to, if you guys are going to do probability and statistics, it's there. So integral calculus, differential calculus, everything that you need is there. And then if you want to learn, okay, maybe you missed a class on something, you just go to that specific folder, then you're going to find the lessons. Okay, so for example, you want to learn maybe SADs and rationalization. So you just open the folder for SADs and rationalization, then kaboom, the videos are there and they are well arranged. So you can see them there. So all these videos are talking about how to rationalize SADs, how to simplify them. So you can watch any of the videos that you want there. Okay. It can not only be SADs, whatever topic that you want. Maybe you want to learn polynomial functions, like how to sketch them, how to solve them using long division, uh, symmetric division. The videos are there showing you how to solve that. So you can watch this at your own time, at your own pace. All right, so make sure I register, and then those who would like to contact me, my number is 0779964010. So you can call me or contact me on that number, or you can simply go in the description of this video here. Okay, so in the description of this video below, you're going to find the link to the website, the link to the video registration guide. Okay, that will help you in case you don't know, as well as my contacts. You're going to find them in the link below. All right, so thank you so much for attending. We end here.